recording. Then we can start the meeting. Let me share the agenda. So first of all, welcome everybody to the 1.121, the Gardener review meeting. We have the following 5 topics today. Rada will start with the improved health checks for rolling updates. It's actually a PR from previous release. We moved it to today occurrence. Then we have Ashwani with a change in dependency-watchdog, now properly reporting when it has scaled down deployment. Tim will give an update about GAP 28 and the current progress of the gardenadm bootstrap for medium touch scenario. Then we have Tim with a change in the extension library, showing new capabilities for shoot webhooks. And finally, Vladimir will show the new DoNotCopyBackupCredentials feature gate. Okay, then let's get started with the first topic and hand over to Rada.
Hello, everyone. I'm going to share my screen. You can see it, right? Okay. So I will start by introducing the issue. This was an issue that Victor actually caught a while back, back in, you can see, 2024, while trying to fix another issue, actually, which was that a node, there was a possibility that a node may not get cordoned while he was trying to debug kind tests. So he actually created this issue and he gave it to me as an intern task to try and figure out what I could do to fix this. So the actual issue was that critical components pod would be reported as node scaling down in situations where it would make more sense for it to be node scaling up. And the reason and the way he actually the way we actually reproduced it is by just getting a local shoot cluster and upgrading the version. Meanwhile, I had the toleration critical components not ready, and just a container that exited. What happened, however, was that during an upgrade of the version, we would get some machines would be registered, more machines would be registered, we would exceed the desired machine count, and it would mark it as node scaling down because it caught it when the machines were already too many and not during the actual rollout. And the reason would be node scaling down, whereas it makes more sense since we're getting new machines to be node scaling up. At least that's what we thought before we found the better solution. You can see here he expected for it to be node scaling up. And so what I did initially in this closed PR was that I fixed it with a simple check here. But as we figured out a bit later on with both Plamen and Victor, because they helped me a bit here, with seeing the MCM logic, because it's still kind of confusing to me. So what Plamen figured out was that, that we had to do another check. Like it wouldn't be just the obvious solution wouldn't be to get the new machine set available and progressing And we wanted to check that during a rollout, we have the progressing condition and that the reason is different from new machine set available. So that's what I did. But still, when I was trying to rework it, I saw that there was some other logic mixed in that wasn't really related to the scaling, really. So what I did was I did a base PR where I moved the node scaling logic into another function, which is now check node scaling, and it would return the action that is happening, which at the time was just scaling up and scaling down. It was just a simple move. And then in another PR, what I did was I added, according to the logic proposed in the first PR, I added this special check where if I had a rolling update and if I was in scaling up and I had met the condition that indicates I'm in a rolling update, it would return the nodes rollout scaling up reason. And therefore, what we agreed on would be that this would override. It would be more important to return this instead of like a rolling update or something else. So that's what we decided on doing. This is maybe a more gardener approach to the problem. What we agreed upon, at least Plumman agreed with Ellen and Aaron. So we agreed that we would do this here, but then again, MCM would create a better logic that would track more precisely all of the worker statuses and such. And I think that's all. Again, thanks for the help from Plumman and Victor and from the MCM people too. And I think that's it.
Cool. Thanks, Rada. Any questions or feedback to this topic? Nope. All right. Then we can continue with the second topic on the agenda, presented by Ashwani and the dependency watchdog changes.
Great. So this is my 5 minutes of fame for a feature change which was introduced with 1.21. This is in the last line. You see here that the gardenlet will not scale up deployments which are marked with this annotation. So what does this mean? Let's jump into a demo. So for the uninitiated, dependency watchdog has two components, a prober and a reader. And the prober basically probes for API connectivity from the nodes, and that the nodes are able to talk to the control plane and update their leases. And if the leases has expired beyond a certain threshold, which is 60%, we will scale down KCM, MCM, and CA to have a meltdown protection. It works on a config map, which basically says you can configure the way you want, but currently it works on KCM, MCM, CA. And then let's see what is the setup like. So we have two seeds, one running on 20.3, one running on 21.3. And as you would guess, there are two shoots. Now let's look into one of the shoots. So this is running on 21.3, everything is healthy. I'll need next 60 seconds of your time to be glued to the screen and not to your phone. So on the left, we have shoot, then we have the deployments of the shoot control plane and the machines which are running on the shoot. you see the pods here, and over the right corner, you will see the dependency watchdog probe messages pruned just for success and failures. And let me see the time. So the last setup was on 7/11/43. We also have Istio here. You might ask, what is Istio doing here? So it was just unhappy component. We don't talk about Istio in our community call so much. So it just says, if Ashwini gets a chance, why not me? And it has decided to come down on us during this demo, literally. So let's wait. I want the next probe to start and then do the magic. So it was 11:25. So sorry for the cap, but there's no way to do it faster. So what should happen is the next probe should be successful. It is, and I just bring down Istio. So now Istio is down. As it promised, it doesn't want me to work. So this change will now make the machines not to be able to talk or update their leases. Hopefully, if this demo works, you will see these machines going into unknown state soon before the next lease probe finds that there is a problem. And if that happens, then we can see further magic of what was going right or wrong. You see this one machine is posting at not ready. The probe is not yet gone. So you see here one machine. And here, hopefully, they should all go unknown soon. And if it goes unknown, yes, all three are unknown. So the demo should happen. And lease probe now should fail. The moment it fails, you will see here the three components, Cube Controller Manager, CA, and MCM will go down. And the moment they go down, yes, you see all three of them are down now. And here they are also vanished, the pods running them. Now, if we go to this shoot and do a reconciliation, might ask, why are we doing reconciliation? I mean, it can happen because an operator thought something is wrong. So let me reconcile. And what should happen now is at around 82%, this guy will do something very crazy. And it will bring up some of the components which it should not. Hopefully, if the demo gods work. So it brings up MCM. Ideally, it should not, but this is the problem. It brings up MCM, which is fine because everything is still unknown. There's no problem. It's all going good. And the lease probe will fail again, and it'll bring it MCM down back. So it's not a problem, and my machine should work. But oh no, why is it terminating? No. This demo is running on this machine, and it's dead. And this is the problem. So the reconciliation happened, and it bring down a machine which it should not. And this is the problem. And agree with this problem if you have 30 worker pools in 3 zones, which is 60 machines, 90 machines, it'll bring down 1 machine per. So MCM is still active. It is doing 1. Now let's remove the outage. So Istio will allow. He's happy that he's done the damage in the demo as what it thinks, but I don't think so. So this is the problem. Now MCM will come up and you will see the probe will succeed. So the probe is succeeded. It brings up KCM, MCM. MCM will bring these machines back to running, which is what we want. But the damage is that 1 machine we lost, which should not have happened. You can say it's too demo centric and I'm creating it, but think about if DWT goes down after it has done this, then all machines will be gone till the meltdown protection happens. So I'll not wait for this to become healthy and running. Everything is fine. So now let's move to what happens in 21. The screen remains same. Now we are in the green world. Again, we'll do the same thing. We'll just check when was the last probe done. Last probe 7/15/51. This will take time. Any which way, we'll wait. It should be wait. It doesn't matter actually, but I want the machines to go unknown, so we'll wait. And what we have introduced while we wait is now we annotate these CA, MCM, and CA with new dependency watchdog meltdown protection active. And Then the gardenlet checks whether this is there, independent whether DWD is up or down. And if reconciliation happens, it will basically not bring them up, and which will safeguard what we saw last time. So hopefully if it does once more minutes, I have some minutes. Yeah, so I've configured it in a way that it needs that 60 seconds to do the magic. So now it is down within a 1 minute because MCM has unknown for 1 minute. These three will go down. And this time when we will do a reconciliation, at 82% of reconciliation, nothing will happen because gardennet has become smarter with this release. Let's see if that happens. Yep, it's going down, 2 are down. Hopefully this will go unknown before this guy here goes for failure. You have to follow my cursor if you're not able to follow my talk. Come on, go unknown. Yes, it goes unknown before the next lease, and this lease will then bring these three guys down, and we will do a reconciliation, and hopefully things will work differently. Yes, it's up. And now if I do a reconciliation, everything should work. Now if you see here at 80, nothing will happen. And we will also see one more thing. This probe has failed, continues to fail, 82%, nothing happens. And if you see these guys, now they have this meltdown protection. And if I edit this deployment, and you can also ignore, so you can say, I want CA to still work because it was just one zone. My other zones are working fine. In which case, you will see that this meltdown protection is removed from this guy in the next reconciliation, and the other two will continue to be. So it sees here, removed annotation, scaling ignored. And if you see scaling got ignored because it has this ignore annotation, ignore scaling, and it has removed the annotation it had put. So yeah, if I bring it up, if you don't believe me, it will work any which way. But yeah, so if you see cluster autoscaler will not have meltdown protection, and CA, KCM, and MCM will have meltdown protection, and they will go up, machines are up, and this will go running. And with this, yeah, KCM is up, MCM will also go up in the next cycle, and we are good. That's all I had. Did I finish? Yeah, 5 minutes mostly. Cool.
So,
that's it.
Nice demo. Thanks.
Cool. Thanks.
Any questions or feedback? Everything explained. Okay. Thanks, Advani. Then over to Tim for the Gap 28 update about gardenadm bootstrap.
Sure. So welcome everybody to the next demo. It probably won't be as fun as the last one, but hopefully similarly impressive. Okay, so I will present the latest changes on the medium touch use case of autonomous shoot classes. If you don't know what that is, a quick recap. In contrast to usual shoot classes where the control plane runs on another seed cluster, an autonomous shoot cluster runs its own control plane as part of control plane nodes, basically. So the typical kubeadm Kubernetes cluster setup. And the GAP 28 introduces a gardenadm tool to manage or bootstrap such classes so that we can use them, for example, as the initial seed cluster or the cluster for running the garden control plane. Okay, So far, so good. We have seen some demos for gardenadm init, which basically brings up the control plane on existing control plane machines that are provisioned outside of gardenadm. But in the usual case, we want to manage them using existing Gardener components like the provider extension and machine controller manager. So this is what the medium touch use case is about. In the medium touch use case, we have a local kind cluster, for example, which is used for bootstrapping the control plane machines using the provider extension and machine controller manager. This allows us to reuse many of the existing components and basically removes the need for Gardener operators to automate all of this with other tooling like Terraform, for example. For running the medium touch use case, there is the gardenadm bootstrap command. And this is what I'm presenting now. We have basically implemented the first 5 steps. Part of it is not merged and released yet, though I will present how it works today. You can also try this out on your machine. There is a getting started locally guide for it. You will find the medium touch scenario in it. It's very simple. You bootstrap the local kind cluster, just like the normal local development setup. And then you can directly start with building the gardenadm tool and running it against your cluster. So this is what I have prepared. This is just an empty local kind cluster, except system components and the registry. There's nothing deployed. So let's watch the namespace that we were working with. And I will start the gardenadm tool down here. First things first, I have to export the image vector override. I can quickly show what's inside. This is basically pointing gardenadm to the images that we have just built with scaffold. So when running gardenadm medium touch up. Okay, so now that we have prepared this step, we can just use go run to run the gardenadm bootstrap command. We will point it to a directory that contains the manifests that we are working with. Can have a short look at this one. So gardenadm medium touch up generates a manifests file, which will contain the shoot and the callout profile and so on and so forth. And as you can see, there is a worker pool that has the control plane configuration. And this basically marks this shoot as an autonomous shoot. Okay. So let's start the process. It will probably run pretty quickly. So one of the first steps is to deploy the Gardener Resource Manager, which we use for managing the provider extension. So we will deploy it in this namespace. This is not to be confused with the Gardener Resource Manager that usually runs for shoots. It's more like the configuration used for seed classes. So this is basically similar to what runs in the garden namespace usually. But nevertheless, we can now see provider local is deployed via a managed resource. It runs in another namespace, but it already runs. There is the machine controller manager. Wow, this is going too quickly to explain. And we have already bootstrapped the infrastructure extension resource. So this one instructs the provider extension to prepare a network like a VPC or something, security groups and so on. And we also deployed the worker extension object. This one contains only the control plane pool In my case, there's only one machine in the control plane pool, so this is added here. We can see that the machine is already available. As you can see in the provider local case, there is a pod running for this particular machine, just like for all the other local shoots. The interesting difference to normal shoots is that the machine goes into this available state. So usually after creation on the cloud provider, the machine goes into the pending state, where MCM waits for the node object to be registered in the target cluster. But in our case, we don't have a target cluster yet. There's no control plane running because we will bootstrap it later on these machines. So it can't wait for the node object, obviously. So in this mode, it runs without a target cluster. And instead of waiting for the node object to be registered, it just sets the machine to available after creating it on the infrastructure. So this is basically the ready state now, and that's why the worker also is succeeded. Okay. So let's take a look at this machine. We can simply access it via exec. It's one of the benefits of the local setup. And as we can see, there is a systemd service called gardenadm download, and it has executed successfully. This is similar to the node init, Gardener node init systemd service that is used to bootstrap a shoot node. It basically downloads the gardenadm binary from the container registry. Similarly, how we download Gardener node agent or the kubelet onto shoot worker nodes. So with this, gardenadm is installed on the machine. This is what we do for preparation, and now we can run it, and this will later then run gardenadm init to bootstrap the control plane, similar to the high touch use case. Okay, this is what is already implemented. So let's take a brief look at the umbrella issue for an outlook. So we are working on this gardenadm bootstrap command. This is what we already achieved. And the next steps will be to deploy a bastion. This is basically used to get a public IP in the VPC, for example, that we can use to access the machines via SSH. So we can jump over the bastion onto the control plane machines and then run gardenadm init there, copy all the manifests to it, and so on and so forth. And once we have done this, we can then export the shoot state, so state of the infrastructure and the worker, into the autonomous shoot so that it will continue to reconcile its own infrastructure, basically. So after this, we no longer need the local kind cluster, except for the local setup where we need some place to run the machines in, obviously. But when you bootstrap an autonomous shoot cluster on a cloud provider, this would be the part where you no longer need the local kind cluster. Yeah, so these will be the next steps, and we will work on it. And hopefully there will be another demo in the upcoming review meetings soon. That's it.
Thank you, Tim. Thanks for the overview. Any feedback from the audience before we continue with the next, Tim? Nope. Okay. And thanks again. And over to Tim Usner for the enhancements in the extensions library.
Thank you.
So this pull request is about an enhancement, but also breaking change at the same time for the extensions webhook library. So if you are a Gardener extension developer and the extension leverages the convenience of the Gardener extension library, this the next 5 minutes is for you especially. So what I didn't prepare much of a demo, but I want to go through the changes that we have here in the enhancement. So what is usually the case for the extensions library is that whenever your extension works with a mutating or validating webhook, we have this this mutator interface, for instance, right? So it is a convenience to only implement the business logic in the webhook, and the extensions library does the rest, like registering the webhook, taking care about certificate creation, rotation, all of that stuff. And what we now did, I first want to point out the breaking change is we eliminated this interface, the mutator with shoot client. So earlier, if your mutator needed a shoot client, then you usually implemented this interface, and then the mutate function got the shoot client inside. So this is now replaced by a new mechanism, and the new mechanism is basically a new interface, which I can show here. So we have two new interfaces. So one is an interface called once shoot client, and the other one is the enhancement. It's called once cluster object. So what you now do is you implement the ordinary mutator interface, and in addition to that, if you need a shoot client or the cluster object, then you would also implement that one, and it simply returns a Boolean. So for instance, I have an extension here. It has this webhook and a mutator, and it says it wants to have the cluster object for its mutating function. And what you can then do is in the mutate function, you get the cluster object or the shoot client, depends on what you need, from the past context, right? So it enters the mutate, then it takes the cluster object out of the context with a predefined key. And the keys are again here. It's the shoot client context key or the cluster object context key. So in this example, we want to have the cluster object. We grab it from the context here, and then we can work with it in our business logic. So for instance, in this case, this is a webhook that is registered in a shoot cluster, and it needs to process the region of the shoot. So it gets the cluster, reads the region, and does whatever it needs to do. Yeah, and the same is true for the shoot client. So this could also work for the shoot client, but then you need to implement one shoot client, return true, and then get the shoot client out of the context. So this would work in a similar method. Okay, I think that's already it from the pull request. So as I said, a breaking change to the new interfaces, and also the addition that you now can get the cluster object in the mutate function. And of course, it's also true if you have validators, then you can also get the objects in the validators, not only in the mutators. Probably also important to mention. All right, thank you.
Okay, thank you, Tim. If there is no feedback, we only have one topic left for today. The new do not copy backup credentials feature gate presented by Vladimir.
Hello. Okay, so I will present this new feature gate. It's about the gardenlet feature gate. It's named do not copy backup credentials, and basically it is used to disable gardenlet copying shoot infrastructure credentials. to be used as etcd backup credentials for the shoots hosted on the managed seed. So yeah, it's not only disabling the copying, but it is also labeling the previously copied secrets with this label, secret backup gardener cloud status previously managed. This is just to make it easier for landscape gardener operators to find out previously such secrets that were previously copied, to clean them up. And the idea behind this feature gate is to foster usage of dedicated credentials for backup with limited permissions and so on, because now the shoot credentials have way more permissions than the backup requires. So I have prepared here a walkout setup with one managed seed and another seed and so on. So if we take a look at the gardenlet, the do not copy feature gate is currently disabled. And if we take a look at the managed seed itself, it is now configured to use a secret named extinct. And on the right side, we are watching two secrets, extinct and extinct 2. The second one is not existing yet. And if I now switch the managed seed to use extinct 2 secret, and the feature gate is disabled. Now, when the managed seed is reconciled, you can see that the extinct 2 secret was simply created by gardenlet. In the local setup, we don't have any data in these secrets, but it is basically the secret of the infrastructure secret used by the shoot. Okay, so if I now switch the gardenlet feature gate and enable it, we can wait for the managed seed to be reconciled, but I will firstly reconcile it. And we will see that this extinct 2 secret, it will be updated, the owner reference will be removed, and that label that it was previously managed will be added. Yeah, but firstly we have to wait for the gardenlet deployment to be rolled. Okay, it is rollout. Okay, and now the managed seed was reconciled, the owner reference was removed, and the secret was labeled. Okay, and now if I edit again the managed seed and try to use another secret that does not exist, okay, like this one, and wait for the gardenlet, it will fail the reconciliation. Here it is, because the managed seed is configured to use a backup secret that does not exist, and the feature gate is disabled, so it will not create this secret. So now this is the expected behavior. This extinct 3 secret must have been created in advance. And if I again switch the feature gate, I disable it, you will see that this secret extinct 3 will be now created. If I just change the watch here, okay, the gardenlet is roll out, and if we now, okay, it is reconciled, and the extinct 3 secret was just created. So yeah, this is pretty much the feature gate. So the idea here is to have this feature gate enabled by default in a few releases, and start using dedicated credentials for etcd backups.
Okay, thanks, Vladimir. And chance to ask questions. Nobody? Good. Then we can close the call for today. Thanks for coming. Next meeting is planned for next week already for the 1.2.2 release. And then we meet again there. Have a nice time. Bye-bye.
Thanks.
See you.
Bye.
Bye.
See you.
Bye.
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 Bye.